Well, hello, this is Dr. Dell again, and in this lesson, I'm going to discuss with you the things you need to know behind learning magic tricks like the one I taught you here for finding the area of a triangle in the previous lesson. If you haven't studied that previous lesson, you might want to go look at that. Because the facts of the matter are, when you get out into industry or the military or into practical projects, there are literally almost an unlimited number of tricks that you can learn using mathematics. I call them tricks because once you understand them, they're not tricks at all, but they just seem to be tricks for people that don't understand them. And I want to discuss that with you and how you can learn those and become quite proficient in mathematics. Now, the first thing you learn when you begin to learn mathematics, you learn about numbers. Numbers, of course, are used to count things, but they're also used to measure things. And then you have to learn how to combine numbers. And so you learn the rules of arithmetic, addition and multiplication and division. And you have to learn how to do calculations, arithmetic calculations. And you have to learn whatever tools you have to work with. Now, I would just tell you back in the old days when I was learning math as a young man, my Uncle Jack taught me how to count. And one of the most important things about numbers is the decimal place system, using powers of 10 to express numbers of any size, large or small. And of course, all of you have learned that. I'm assuming that you know that. And if you don't, that's the first thing you want to learn. And then you've got to learn how to combine these numbers, how to add them and subtract them and multiply and divide, and the so-called rules of arithmetic. And you need to learn that. And if you don't know that, that's another thing then you're going to really need to learn. Now, once you've learned those things, then you have to begin to learn how to do calculations with these numbers. And this is where things now can get quite interesting and challenging. Back in the old days, we had to use pencil and paper and manual algorithms for doing it. We didn't have any real sophisticated tools. If you were going to go into engineering, there were some tools, things called slide rules and logarithm tables and trig tables that you could use. But those were kind of tricky to use too. And that was something that you didn't usually learn until you were either late in high school or actually off into college usually. Now, it turns out that in modern times we have tools that make all of this much, much easier. This TI-30XA is a scientific calculator that will let you do any kind of arithmetic calculations you're ever going to need to do very quickly and very easily. This is a modern tool. The very first calculator, scientific calculator, came out in the early 1970s. And it was very expensive compared to this, over $2,000. It wasn't nearly as good as this one. And they just kept improving over the years and getting less expensive. And today, this is a very, very powerful calculator. It'll do any kind of practical math you're ever going to want to do. It costs less than $10. And really, one of the first things you want to learn to do is to use this tool to do your calculations. Now, the second thing you're going to learn is geometry. Geometry, as you know, is all about physical objects. It's straight lines and circles and triangles and things and a bunch of concepts. And you use geometry then to model the real world. When you're out doing problems in the real world, whether it's industry or the military or projects you're doing, landscaping, carpentry, you name it, you're going to be using geometry. And it turns out you've got to take numbers and geometry and combine them because you want to know how long something is or what is the area or what is the volume. And to do that, there's a thing called algebra. And algebra consists of a bunch of rules and tools also that you can use then to figure out problems with geometry and numbers. And that's the thing that you're going to really want to learn, and I'm going to tell you how to go about that today. Now, of course, the big question is how are you going to learn mathematics? How are you going to learn these things? Well, let me tell you a little bit about my background. When I was a very young boy, like 4 or 5 years old, my Uncle Jack was an old man, was a barber actually, and he taught me how to count using tens. So, for example, I learned that 496 was the same as 4 times 100, plus 9 times 10, plus 6 times 1. He taught me to count to 100 or to 200 just by going up by powers of 10. And, of course, this is 10 squared, 10 to the first power, and 10 to the 0. Now, you know all this, but I learned that when I was like 4 or 5, how to count. I didn't learn how to divide or add and multiply. I just learned how to count. And then he taught me something from geometry he was pretty proud of, and he's very useful. He called me the 3-4-5 rule. Have you ever heard of the 3-4-5 rule? Well, here's what he taught me it meant. If you had something that was 3 feet long here and 4 feet long here, and then if you had this, drew this line down here, and this was 5 long, so let's say this was a post here 3 feet high, you come out 4 feet, and you draw a line down 5 feet, then this was what he called it a square triangle. Of course, that didn't mean much, but that's what he called it. And what he really meant was that this angle here was the same as the angle in a square. Now, today we call that a right angle or a 90-degree angle, but he knew that, and this was important in construction or when we were setting up fence posts or doing things of that sort of thing. So he taught me a little bit about geometry here way back when I was like 5 years old, the 3-4-5 rule. And he also knew, as I recall, that if you multiplied every one of these by 2, like the 6, 8, 10, that would still give you what he called a square triangle, a right angle here. And so this was something I learned when I was very, very young. I learned how to count, and I learned the 3-4-5 rule. And he didn't really know why this was true or where it came from. He just knew this was true, and it's something that he taught me. Now, my Uncle Jack didn't know very much mathematics, but he was a pretty wise man, and he told me that if I would learn mathematics, what he considered practical mathematics, that it would open up many, many opportunities to him. He called it the open sesame of opportunities. He said that a lot of people were very successful because of their knowledge of math. Well, what he meant by math, of course, is what today we call algebra and geometry and trigonometry and pre-algebra. Now, it took me many, many, many years to learn practical math. In fact, I didn't really master it until I was probably 18, 19, 20 years old, all the way through high school. Well, it turns out today that with modern technology and what we know today about teaching math and how we can deliver lessons today, a person can actually learn all of the practical math they need to know in probably about 3 or 4 months of their time if they'll work, a half an hour to an hour a day, 4 days a week. And we teach this ourselves with a program we call the Practical Math Foundation. And I want to tell you about that. And you don't have to take our course, but here's what you need to learn. The very first thing that I recommend that you learn is how to use the calculator. Now, the calculator that I recommend, as you very well know, is the TI-30XA. This little $10 calculator, actually less than $10, when they first came out back in 1972, a much more primitive version of this cost over $2,000 in 2015 dollars, today's dollars. It was $395 in 1972, which is worth over $2,000 today. If you could take this calculator right here back 100 years ago, say to 1915, around World War I, this calculator would have made you a rich man, because this would let you do math problems so much better and faster, and in fact do problems that they just weren't practical to do back then. It would have just been a tremendous thing. In fact, if they'd have had this calculator when they did the Manhattan Project, where they invented the atomic bomb, it would have just made their life so much easier. This is just almost like a magical tool. So you want to definitely learn how to use one of these. There's a lot of other tools out there today, but this is a very good place to learn. This is the one that I think you should start with. Now, what we do is we teach you the things that we feel you'll need to know to do practical math. And so there are actually about 16 lessons here in the calculator section that we do. Some of these down here we do later on. They're not necessary in the beginning. And you're going to learn how to use, obviously, the regular keys for operations. You're going to you learn how to use the x squared key, the square root key, the reciprocal 1 over x key. You're going to learn how to use the 3 trigonometry keys. You're going to learn how to store things in memory and recall it, and very importantly, the fraction keys. This does everything you want to do with fractions. Multiply them, divide them, convert them to decimals, back and forth. How to use parentheses to do complicated things. How to use negative numbers. All of that is something that you're going to learn right off the bat, and it takes most students about 2 weeks to go through. Each one of these lessons would be a video lesson, kind of like the first one you took. Then it would teach you a concept. Then you would do a lot of exercises on it. Then you take a quiz, like climbing a ladder. When you pass that, you go to the next lesson and the next lesson. There's no such thing as a C in math. You either understand it or you don't. And so you're going to learn it as you go. You might go faster or slower than someone else. That doesn't really matter. It's going to be self-paced. But the point is, it's very easy. In fact, people are always amazed. They go through these calculator lessons and they say, wow, that was really, really easy. Now, what's the next thing you should learn? Well, the next thing you should learn is what we call pre-algebra. We want to be sure that you understand the rules of arithmetic, the rules for addition, what negative numbers are, the real number line, fractions, the distributive law, how fractions work, squares, square roots, reciprocals, and exponents. These are things that you need to know for practical math. And now there's only 10 lessons here, and it goes, again, pretty fast. And a lot of this would be review for you if you've already studied elementary math. But we want to make sure that you really fully understand that. And now what would come after pre-algebra, do you suppose? Well, you probably guessed it from the name. The next thing is algebra. Now, you may or may not have studied algebra. Today, most high school algebra books are several hundred pages long. I've seen them over 900 pages long. But you don't need anything like that for practical math. There are actually 10 lessons we give you in algebra, and these are all that you need to know for practical math. And they're very easy to learn. You're going to learn about the rule of algebra, how to use it is a very simple thing. And each one of these, again, is a lesson with exercises. And when you learn to do these particular algebra rules and techniques, then you're going to know all of the algebra you need for practical math. Now, the next thing you're going to want to learn, and this is where it really starts getting really interesting and useful, and that is geometry. Because what you want to know in the real world is how long should something be, what should be the area of something, what should be the volume of a three-dimensional object. And so you begin to learn about these things. First you start and you learn about straight lines and angles, and then parallel lines. Then you start to learn about triangles. Now, at this point in the fifth lesson, I teach you something called the Pythagorean theorem. Well, in a nutshell, what it says is that if you have a triangle that's a right triangle, and these are sides A, B, and C, the C squared is equal to A squared plus B squared. That's where my Uncle Jack's 3, 4, 5 rule came from. 3 squared plus 4 squared is 5 squared. 8 squared plus 6 squared is 10 squared. Now, he didn't know this one, 5, 12, and 13. That also satisfies the Pythagorean theorem. You take your calculator and verify that. Now, you want to learn about a lot of other things in geometry, all about circles and polygons and surface areas and volumes of cones and blocks and cylinders. And there's about 20 lessons we give you. And when you get done here, you're going to know all kinds of things about geometry that is going to help you in solving all sorts of real-world problems. Now, it turns out that the most important polygon in geometry is a triangle. They're used throughout industry. It's the only rigid polygon. And there's a lot of things you can't solve about triangles using just geometry and algebra, and you need something called trigonometry. Now, in the old days, trigonometry was pretty difficult, but in modern tools, when you have the modern tool of sine, cosine, and tan, these are the trig functions on the calculator, trigonometry becomes very easy. In fact, this is probably the easiest of all the three sections that we cover. Now, we talked about the Pythagorean theorem you learn in geometry. Now, when you get into trigonometry and you can start doing things with the so-called trig functions, you can get a generalized version of the Pythagorean theorem. Suppose this triangle A, B, and C, and this angle here is not necessarily a 90-degree angle. Well, then you would have C squared equals A squared plus B squared. That looks like the Pythagorean theorem, but now you've got to put in a correction factor. Minus 2 times A times B times what's called the cosine of the angle 1, this angle here. And then it turns out that if you want to know the area of this triangle, the area is 1/2 A times B times the sine of angle 1. And this you learn in trigonometry. In fact, we taught you this back in geometry. And that was the key to this algorithm that I taught you earlier. And now I'm going to go over this very fast. This isn't really training we do in our class. We go much slower, but just to show you. You take this generalized Pythagorean theorem, and we want to know what is the cosine of angle 1. So we bring this over to this side, we transpose, bring the c squared over to here, a squared plus b squared minus c squared. Then we divide both sides by 2ab. That gives us a cosine of angle 1. Now if we take the inverse cosine of the cosine of angle 1, we just get angle 1. So what that means then, when we want the area of the triangle, is 0.5 times a times b times the sine of what? Well, the inverse cosine of the cosine of angle 1, and that's the answer. And so this was the formula then that I used to create that long algorithm that I gave you earlier. Because if you go back and look at it, at the very bottom I showed you what we had done here, what you'd be displaying. And this was 0.5 AB sine, inverse cosine, a squared plus b squared minus c squared divided by 2ab. This was why this magic worked. That's why this algorithm worked. And that's the kind of thing you need to learn and fully understand when you learn practical math. And as I told you earlier, you can learn all of this probably in about 50 or 60 hours of your time. So if you would like to have the open sesame to practical math so that it will open up opportunities in many arenas for you, go to our website, www.triadmathinc.com, and simply download the syllabus and set about and learn the subjects that we've taught you here. If you need help and you want our help, you can buy our program and learn it from us directly. I'd say you can learn most of this in about 60 hours of your time 1.5 to an hour a day spread over about 4 or 5 months, and you should have it. And then you'll have the open sesame.